Hey guys, Mr. Gucci here with a help video for Unit 11 States of Matter Final Exam Review. So this is actually a pretty interesting unit, I would say, coming right at the tail end of finishing up our stoichiometry chapter. We were burnt out on math, and so this unit pretty much entirely eschews mathematics altogether. Uh, most of the stuff we covered in this unit was terms and concepts. So I would say the best way to prepare for this unit is to review the terms, all right, using the Quizlet provided, and just go through the notes. And as we go through here, we'll see that terms are really the most important facet of this. All right. So, first of all, we talked about the three states of matter: solid, liquid, and gas, and how they are defined and differ from each other. We also talked about the three factors that affect what state of matter a substance is in. Why are some things solids, other things are liquids, and other things still are gases? Well, there's only three factors: the kinetic energy, how fast the particles are moving. All right, the faster the particles are moving, the harder it is to keep them together as a solid. This is why when we increase something's temperature, i.e., make the particles vibrate more quickly, you can get something to melt or to turn into a gas, to boil. You are vibrating the particles so much that they cannot be held together. Then there's intermolecular forces. These are the innate attractive forces contained within certain molecules and atoms that pull them together. Some substances have stronger intermolecular forces, for example, plastics. The reasons why plastics hold together so well is because they have a lot of intermolecular forces between the molecules, which other things like carbon dioxide do not have very strong intermolecular forces pulling the molecules together, which is why carbon dioxide spreads out as a gas. And lastly, external pressure. It doesn't matter how much energy a particle has or how strong the intermolecular forces are. If you push the particles together hard enough, you can get them to become a liquid or a solid. Even something like helium, you squeeze helium gas hard enough, you can turn it into a liquid. Squeeze it harder still, you can even turn it into a solid. These are extremely high pressures, though. Not something we encounter on a daily basis. And then altogether, the phase diagram, which is featured down here in your review packet. All right, be familiar with the phase diagram. This unit also contained a chapter on solids and on liquids, not gases, though, since as you now know, we had a whole chapter on it. For solids, you need to know some terms. What are allotropes? What are the difference between crystalline and amorphous solids? And you need to know what the phase changes are. What does it mean for something to melt and to freeze? What does it mean for something to undergo sublimation? This is something that's going to come up on the final. All right, these are terms that describe um, a solid turning directly into a gas without going through a liquid phase. I showed you some dry ice to demonstrate that. Okay. And then there was the section on liquids. Again, the phase change. All right. What does it mean for a liquid to vaporize? And what's the difference between boiling something and having it evaporate? All right. You need to understand how vapor pressure and atmospheric pressure interact to cause a substance, a liquid, to boil or not. And as far as vapor pressure diagrams go, I don't think there's a vapor pressure diagram on the final. So if you just focus on the stuff up here, you're going to be pretty good. All right. Once again, you should be focusing on the Quizlet and running through the notes, making sure you fill this in. All the solutions for these questions have been uploaded with detailed explanations. I'm not going to make a help video for these because there's no math problems here, just explanations which I've provided. All right. Good luck, guys.